Okay, so let's see. Determine the end behavior of the following function. What do we mean, or what do they mean by end behavior? When they talk about end behavior, they mean what happens to f of x when x is a very, very, very large number, very, very large positive number, or a very, very, very large negative number. So we say the end behavior because if you represent the function as a graph, it's going to be on the extreme left side or the extreme right-hand side, right? I hope everybody is okay with that, right? When a graphical representation of a function, you have the x-axis, and then to the left is the negative number, right is the positive numbers. So the foot center, the absolute value, right, the actual number gets bigger, but then to one side is negative, and so that we call the end behavior. We want to know what values the f of x takes. Is it very negative? Is it very positive? Is it equal to 0 or whatever? These are all the, like for a polynomial function, the only option is it's either really, really big in a positive sense, or it's a very, very big number in a negative sense. So what we look at, so now I think, wait, let me take it out. I need the whiteboard. Yeah, but let me write down this. It's plus x. What's the function that I wrote? It's plus x minus 1. Yeah, okay. So, all right, the whiteboard, please. So the function we had was this one, right? Minus, it was f of x equals to this. Why does it fade? It's just, I'll just leave it like that because I don't know how to enlarge it. Okay, so what we need to know is that what determines the end behavior is the highest power of x. Power, I mean, we have here x to the minus 2 x to the cube minus 3 x squared plus x minus 1. The one that is the highest power is this one, right? 3 is the biggest one. So what I'm saying is what happens to this polynomial function is what happens to the highest power. Here we have x cubed. I know that x cubed kind of, this we kind of know from just drawing a lot, like it kind of looks like this. X cubed looks kind of like this. When x is a very, very big number close to infinity, x cubed is also positive and a very large number. When x is a very negative number, x cubed is also negative and very, very large. But then I multiply by minus 2. So that's going to flip it. So it's going to start looking like this. Yeah, this is my minus 2 x cubed. So when x is very large but positive, this guy is going to become more and more negative. When x is negative, this is going to be negative, but then times minus 2 is going to be positive. So we say that the end behavior of this function is as x goes to, and this is how they say, like positive infinity. So just to say, like as the number becomes bigger and bigger, then f of x goes to negative infinity. And then as x goes to negative infinity, when the number is more and more negative, then my f of x is going to be more and more positive. So it's actually close. And so this is what we say, this is the end behavior of the function. So then you can ask, like, hey, what about these other guys here? These other guys don't matter because when x is a very large number, the behavior is going to be driven by the largest power. because the cube is going to grow so much faster than anything that the square or the x can do. So you don't have to worry about it. Yeah, this is a concept that if you ever do calculus, it will show up again. Yeah, it's a concept, what they call the limit. In the limit, when x goes to infinity, f of x goes to negative infinity. In the limit, because we say limit because it's never really there, right? Infinity is not a number. So this is a way to say as x gets more and more negative. So in the limit, when x goes to negative infinity, f of x will be positive infinity. Yeah, is that okay? So the end behavior is just so I can, let's try another one just randomly.
So Professor Yan, are you saying the answer, like the answer for this is what you've written there, that as x goes to infinity, as x goes to positive infinity, the f of x goes to negative infinity, and as x goes to negative infinity, the f of x goes to positive infinity. That's the, that is how we would describe the power function. That's how we would describe the end behavior of that function.
Yes. Let's go with another one. So let's say x to the fourth minus 3. Somebody's erasing for me. Thank you. And minus 3x cubed plus 5,000. I don't know, something like that. I
cannot see what you're writing.
Am I too far away from?
I can see it.
If you move, you can move the board. There,
yeah,
I
move the
found
board.
it.
I'm at the left high. I'm at the corner.
It only lets me go.
Do you see the f of x and new f of x? F of x is x to the fourth power minus 3x cubed plus 5,000. I want to know what's the end behavior of this function. So like I said before, all we need to focus is the highest power. This is the highest power. It's kind of like politics. Only what the higher power says matters. If you remember that, low power people don't matter at the end. So it's like x to the fourth. So we know x to the fourth, it's only going to give me positive. It's like x squared, but then again, right? X squared times x squared gives me x fourth. So if you're negative x to the fourth is still going to be positive. If you're positive, it's going to be positive x to the fourth, right? So I don't know how the function looks like actually, but I know that it will be like this at the end. Sorry, wait. Like when I move to the right, these numbers are going to get larger and larger. And then when I move to the left, negative x to the fourth is going to be also a very huge number. So in this case, I say when x goes to infinity, positive infinity, f of x goes to positive infinity. And when x goes to negative infinity, f of x still goes to positive infinity because the highest power of x here is x to the fourth. Before we had x cubed, which would actually change the sign when x changes sign. However, if now I have if I change my function a little bit by multiplying the x to the fourth by -7, then everything here changes, right? Now this is going to be negative and this is going to be negative. Do you see that? Because a -7 is going to bring this guy down, right? This is going to become -7, whatever, and then this guy is going to come down, so it's going to be -7 something. So this is what I mean by the minus here. First, you check the sign of this guy, and then the multiplicating factor will actually matter. If it's positive, it's not going to change the sign of an x to the fourth. But if it's -7, then it's going to flip the sign of what your x to the fourth gives you. Right? And what we know is, so I'll say this slowly. So if you rewatch, you can think about it careful. If the power here, this guy, the highest power is an even number, you know that the end behavior will be the same. They will either both go to positive infinity or they will both go to negative infinity. If this guy is odd, if the highest power of x is an odd number, like 3 that we had before, if it's odd, then one end will be very positive and the other end is going to be very negative. Because think about how x cubed or x bar, x the fifth power or x7 behave. Yeah, they all kind of look like that.
So if
So
they're
what goes up?
if they're if the biggest number is even, then we get the egg or like the bowl shape, and then if it's odd, do you get the slide?
Yeah, but it's either this way or this way. Depends on the sign of what's multiplying that biggest power. So it's up if it's positive, and then if it's down if it's a negative times the even power, and it's like the, I don't know, it's like an n like that if it's positive number times the odd power, and it's going to be the inverted, and if it's a negative number times the odd power.
Okay.
Is that okay?
So is it fair to say, Professor Yan, that on this one, that x to the third, x cubed, the negative 3x squared plus x minus 1, those are like just distractions. We don't need to consider them, and when we're looking at the end behavior.
Right. But you do need to make sure that they are ordered properly, right? Because a tricky question would be if they put x squared first before the x cube, you know, and then you miss that. So you need to check like who is the highest power. It doesn't have to be the first term, because I can write my expression in any order, right? I could put -1 first. I could do -1 plus x minus 3x squared minus 2x cubed, and then you are like, who's the highest power? So you have to see what's the highest exponent of x.